All right, welcome. Today, we're going to pull back the curtain on the hidden structure that pretty much powers everything you do online. We're going to talk about taming the absolute chaos of modern information by understanding the art and really the science of database design.
You know that feeling, right? You open a spreadsheet and it is just a complete and total nightmare. Or you're trying to find a contact in a list that has absolutely no order to it. We have all been there, just drowning in digital clutter. And it's frustrating, it's inefficient, and it really feels like there's no way out.
But what if I told you that for every single mountain of messy data out there, there's a professional, structured way to bring order to all that chaos, a deliberate plan to make it all make sense?
And yep, that plan is called database design. And look, this isn't just some dry technical thing. It is the secret sauce. It's the fundamental strategy for organizing information so that our apps, our websites, our entire digital lives can actually run smoothly.
Okay, so the best way to wrap your head around database design is to think like an architect. I mean, before you lay a single brick for a new house, you need a detailed plan, right? A blueprint. Well, that exact same principle applies to data. This is the core idea, right here. In the world of data, our blueprint is called an entity relationship model, or you'll just hear it called an ER model. It's the master plan that lays out every single piece of information and exactly how it all connects long before anyone writes a single line of code. And this whole process usually happens in 3 stages. First up, you've got the conceptual design. That's kind of like the architect's first sketch, the big ideas. Then comes the logical design, which is like the detailed floor plan. And finally, you get to the physical design, which has all the nitty-gritty construction details. So if we're looking at this data blueprint, what are we actually seeing? What are the building blocks? Let's break down the surprisingly simple language that makes up every single one of these ER models. First up, we have the entity. An entity is really just a thing we want to keep track of. Could be a person, a place, an object, an event. Think of these as the main nouns in our data story. In that house blueprint analogy, these would be the big things like the living room or the kitchen. So for a university, your main entities are going to be student and course. For an online store, it's got to be product. For an airline, it's flight. See how these are the core subjects? They're the center of whatever universe we're trying to build. But an entity all by itself is just a label, right? We need details. And that is where attributes come in. Attributes are the properties or characteristics that describe an entity. So if entities are the nouns, attributes are the adjectives that give them all their color and detail. For instance, if our entity is student, its attributes would be things like a unique student ID, their first name, their last name, and so on. These are the specific little pieces of information we absolutely need to know about each and every student. Okay, so we've got our nouns, the entities, we've got our adjectives, the attributes. What are we missing? The verbs. Relationships are the connections, the associations that link our entities together and show how they interact. This is where the data starts to get really powerful. So imagine we have our student entity and our course entity. Without a relationship between them, they're just two completely separate, unrelated lists of information. We know some stuff about students, and we know some stuff about courses, but we have no idea how they connect. But now, look at this. We add a relationship. We define that a student enrolls in a course. And bam, suddenly that simple connecting line gives our data meaning. It gives it context. Now we can actually answer questions like, which courses is Jane Doe enrolled in? So the whole point is that relationships turn these isolated data points into a powerful, connected web of information. Okay, now that we've got the fundamentals down, let's level up and look at a couple of more advanced features you'd find on a really sophisticated data blueprint. These are the things that help us model complex, real-world situations a lot more efficiently. First, there's something called generalization. Now, this is a really clever way to avoid repeating yourself. Think of it like this. A house and an apartment building are both types of residential structures. Generalization lets us group similar things that share common traits into a single higher-level category. A classic example is the employee. All employees have a name and an ID, but some are paid a fixed salary while others are paid by the hour. Generalization lets us create a main employee entity with all the common stuff, and then we create specialized subtypes for salaried and hourly employees that have their own unique details, like a salary amount or an hourly rate. Next up, there's aggregation. This one sounds a little complicated, but the idea is actually pretty simple. It's all about bundling an entire interaction, a set of entities and their relationship, and then treating that whole bundle as a single thing.
For example, think about an employee working on a project. Well, the combination of that specific employee, that specific project, and the works-on relationship between them, that whole package can be bundled together and called a project assignment. And now we can manage that assignment as one single unit, which, trust me, simplifies everything.
So we've looked at entities, attributes, relationships, even some of the advanced stuff. But let's zoom back out. Why does spending all this time on a blueprint actually matter in the real world?
Well, because the amount of data we're all dealing with is just staggering. Get this, 90% of all data in existence was generated in just the last 2 years. Trying to manage that explosion of information without a solid plan is, well, it's a recipe for absolute disaster.
A good blueprint, a good design pays off big time. It gives you stability, which means your data stays accurate and doesn't get corrupted. It creates efficiency, so you can find the info you need in a split second. It gives you scalability, making it so much easier to grow and add new features down the road. And maybe most importantly, it gives you clarity, so anyone who works on the system can actually understand how it all fits together. And really, that's what database design is. It's the strong, thoughtful, but completely invisible architecture that is holding our entire digital world together, from your social media feed all the way to your online banking. So the next time you use an app or a website, just take a second to think about the elegant design that's humming away right underneath the surface. What unseen blueprints, what carefully planned entities and relationships are structuring your digital life at this very moment?